In this video, I want to look at the idea of correlation and scatterplots. So I'm going to start with what a scatterplot is. A scatterplot is very useful for exploring the relationship between 2 or 3 variables. We'll put one variable along the x-axis and the other along the y-axis. And then we'll plot points on the graph to represent data points. So let's look at how to do this using R. For this, we use the command plot, and then we have our two variables. Variable 1 is our x-axis, variable 2 is the y-axis. And we can use some of our commands like main equal to indicate the title of the graph, xlab to indicate the label, ylab for the y label, and col for the color of the graph. So we can change up things a lot like that. So let's look at an example. Here I have RStudio. I've went ahead and read in this data that I have. It's called bearsdata.txt. And then I use this command attach br. So I called this table br. And the attach br means I'm not going to have to use that to identify the fact that I'm referring to that table. Everything I use is going to automatically assume it's coming from that table. I'm going to run the command plot chest.g, weight. So this is chest girth versus weight of these bears that I've looked at, and I can see my scatter plot down here. And there are a few settings I can do to change this up. I can use the main command to give this graph a title, chest girth versus weight in bears. I do like the weight on the y-axis, however, we're going to change this chest.g to what it actually represents. So I'm going to use xlab equal to chest girth to actually change it to the chest girth. And so we can see this scatter plot here, and we can start to see how this is related. We can see that as the chest girth increases, so does the weight. So we can see this relationship in this graph here. I can also use this command pch equal to 19 to change the way the dots look. And changing up this number is going to change the way these dots look in our graph. So now that we've got the basics of scatterplots, let's look at correlation and what that means. When I'm looking at correlation, I'm looking at three things: linear versus nonlinear correlation, weak versus strong correlation, and positive versus negative correlation. So let's look at each one of these. For linear versus nonlinear, what we're looking at is, does the shape of the dots and the shape of the graph generally look like a line, or do they not? Here, I have two scatter plots. This one on the left is going to be a linear correlation because we can see that it generally has the shape of a line moving up and to the right. This one over here is nonlinear because we can see that it does have a pattern, but it's no longer a line. It looks much more like a quadratic. And for the purposes of this class, I'm really going to be concentrating on linear correlation. So as I talk about my other features of correlation like weak and strong and positive and negative, I'm really going to be talking about linear correlation whenever I refer to those. So next I want to look at weak versus strong linear correlation. Here I have two scatter plots. The one on the left is going to represent a weak correlation, and the one on the right is going to be a strong correlation. In general, the weak versus strong tells me how close they are to an actual line. If I were to draw a line through the middle of this, or through the middle of this, how close are the points to the line? The closer the points are to the line, the more compact they are, the stronger of a correlation it is. The more spread out they are, the weaker correlation we have. Now I want to look at positive versus negative correlation. Here are my two scatter plots. This one on the left is a positive correlation, the idea being that it moves up and to the right. As the x-axis gets bigger, so does the y-axis. The one on the right has a negative correlation. As x gets bigger, y gets smaller. It moves down and to the right. And if we think about these as lines, this one has a positive slope and this one has a negative slope. And this is where these things get their names. The idea being, do they both increase together or do they increase reversely? As one gets big, the other one gets small. Next, I want to look at the idea of the correlation coefficient, which is denoted by R. So this is a number that tells me how weak or strong my relationship is, as well as if it's positive or negative. The correlation coefficient is a number that's between -1 and 1. The closer this number is to either 1 or -1 means I have a stronger correlation. And the closer it is to 0 means weaker or no correlation. And the sign of the correlation coefficient determines whether it is a positive or negative correlation. And this can be a really hard thing to calculate, so let's look at how to find this in RStudio. Here, I still have my data from my bears. And I can use this command COR for core, and then put my X and my Y variables, chest.g and weight, and it will give me my correlation coefficient, in this case 0.9599134. That's very close to 1, which tells me this is a very strong correlation. And in addition, it is a positive number, so that tells me that this is a positive correlation. If I look at the scatter plot for the net girth versus the head weight, we can see this graph right here. And when I find this correlation, I can see it's 0.8138. So it's a weaker correlation, but still fairly strong, still very close to 1. And so this can give us a lot of information. This correlation coefficient tells us whether it's positive or negative, as well as exactly how strong of a correlation it is.